Right, okay, question 1. It was about application packages. Pretty GCSE. Okay, so you've got to try and, it is all about context, this question. So it's got a small manufacturing business, uses network computers with closed source application software. Right, a spreadsheet application package is used to calculate employees' wages. Fine. Give one benefit of using a spreadsheet compared to doing it manually. Well, I mean, there's loads of things you could say. I'm not going to bother writing any answers in it on this one. I will just talk through it. But there's loads of things you could have said, but you need to be specific, don't you? So you're talking about things like accuracy, aren't you? It's easy when you're doing things by hand. You could make mistakes. In a spreadsheet, if you make a mistake, it's going to be a mistake for all of them, isn't it? You're using the data, so that's what you're using the spreadsheet for. It's the time saver. It's the accuracy and the speed. As soon as you've got the data in, the spreadsheet's calculated it. It's not the same if you're doing it manually. Okay, so it was only 1 mark, so it was just something sensible but related to. I can't remember what they had on the mark scheme. If I just squeeze through to that. Oh, now that I can read it because it's so small. Yeah, a few mistakes. It does the calculations and it's to do with speed. But you can't ever say, don't just say few mistakes. Don't say faster. Faster than what? You've got to be specific with this stuff. You've got to tighten up your language, everybody. Right, the next bit was universally disastrously answered. Okay. They don't want to know about particular manufacturers' products. I don't care about, if I'm talking about, they look at what they wrote. They said a spreadsheet. They didn't say Excel, did they, or Google Sheets. Don't give me specific products. Give me the family of products. That's what they're looking for. So application packages. So you could have gone for presentation software. You could have gone for database software. You could have gone for word processing software, email software.
Would PowerPoint be presentation software?
It's a brand. It's a product. So I think they're going to be mean on marking those. So I try to be moderately mean on this. Now, the other bit of this is it's got to be related to something they're trying to do. So if you're saying things like emails, the emails are used for what? Communicating with internally, communicating with customers. You know, you've got to have a solid example, and you can't just be generic about this. For the PowerPoint, if you're going to say presentation software, what if it's a manufacturing business? I don't know, for doing like weekly meetings to put information packages together for meetings. But you've got to try and tight. You can't just say for doing presentations. Presentations of what? If you're going to say word processor, that would be like, I think a few of you did try and put like typing up minutes of meetings and things, which is fair enough. That's not a bad one for that. If you're going to use a database, you're going to have to start getting creative about what it is they're going to store. So it might be customer lists and things like that. But all of it has got to be related. Don't start like 3D modeling software without knowing anything about their manufacturing business. They haven't given us something base to start putting daft things down. Okay, so you've got to be specific, but it's got to be general applications.
So, where did you put the mark scheme for this paper?
It's on the assessment channel. It's up at the top. Paper 1, paper 2. It hasn't shown it all, has it?
Go into the comments.
Yeah, you got.
You need to pick view reply.
You got to do the replies.
Oh, it's in the replies.
Yeah,
Well, it has to be because there's no other way of doing it. Not that it's rendering them on the screen for me currently. It's got some nice boxes.
It's not rendering them for me either.
No, is it just bugged up as we've started?
Sometimes when you switch it doesn't like
Yeah.
that's the original.
It thinks you're not logged in. Yeah, they're back again now.
Refresh the page.
Yeah, stupid thing. Yeah, so just have a look. If you ever get an application, not that we should get one again, but if you've got an application packages question, they're the application packages. You might get something weird if you've got like someone doing 3D modelling. You can talk about CAD software and stuff like that. But yeah, you've got to stick to it. Right. Oh, this. And then the next one, closed and open source. Right. The drawback to closed source means you can't modify it. So if you want to like make some tweaks to how it works for you, and you've got people capable of doing that, you can't with closed source software. The other side of that is if you've got bugs in the software, you're reliant on that software company doing that. You have to wait. You can't. You might be able to say there's these bugs, we're reporting them, but you can't dictate when they're going to fix them. You've only got to look at any closed project to see that. Even with open source projects, it doesn't mean things are going to get fixed. Okay, but if it is open source, you might have the capabilities of fixing it. This is a manufacturing firm. They're not likely to have a lot of hardcore programmers working for them. But they could employ someone else to work on tweaks and fixes. Okay? You know, a lot of you said it was cost, but I think that's a dodgy one to go down because you've got to really explain what you mean by that. Some open source software doesn't mean it's free because you might pay for support. If you look at Linux, Linux is free, but if you want to run it in a commercial environment, you're generally going to pay for support. So what is cheap about open source? It depends, doesn't it? Because you've got to be careful when you talk about those ones. Okay. Moving on. I might be able to get through this whole question in one clip. Right. BIOS. Right. True or false statements. Make sure you read the columns correctly and whether you're writing in the right way. So BIOS stands for Boot Input Output Standard. No, it does not. Basic Input Output System. Okay. It's not standard. So that's false, that one. BIOS can be used to alter hardware settings, such as which storage device the computer boots from. Yeah, that's one of the settings for the BIOS. Remember, there's two parts to the BIOS, the program and the data. That's to do with the data, but the BIOS program lets you modify that data. And then the doozy, BIOS settings are stored in RAM. No, they're not. They're stored on a little either memory cell backed up RAM, low power RAM, or they're on flash storage, NAND storage that doesn't require a battery, but they're not in RAM. If they were in RAM, your settings would be gone. That's what happens when the battery dies on a motherboard. It's like having it in RAM. I don't know. That was dozy, that question. I don't think anyone. I don't know how many people got through. I don't think there were lots got through. Right. Now, this one. You saw the word virtual and you went off on one, talking about virtual memory, loads of you. It says virtual storage. And it's talking about backups. Virtual memory's got nothing to do with backups. You should have read the whole sentence. We're talking about backing things up to external computers, either through the cloud or to another server in another part of your building. You're making things robust in case of total hardware failure, so you can recover things. And it's perfect for backups because you don't need to always access it. It doesn't have to be immediately accessible. You need to know you can connect to it, but it doesn't need to be there and then. It's a different set of devices. That's why we do backups to other servers. Usually companies used to have their own secondary servers. And what you do is you host them in a location not near your main servers in case you have a fatal fire or somebody drives a truck into your server room, which I've seen.
What?
Yeah.
Really?
Yeah. Ideally you don't put server rooms on external facing walls.
Or ground floor?
Yeah, it depends, but sometimes you're limited. So that'd be one way of avoiding that. But yeah, if someone totals all your hardware, you should be able to, if you've got all the files, just have them installed on temporary hardware. And there's firms that do this, disaster recovery firms. They'll like provide new servers upload all your data onto it and get you up and running again. We used to have it at Palmer's.
Really?
Yeah, it cost a fortune, but it was worth it.
Did you ever use it?
No, luckily. Sometimes we had to use them to come in and help us when we had a fatal on the server, but not all the hardware had died and blown up. But it can happen. A lot of server rooms have got argon defense systems to kill all the oxygen. They flood the room with inert gas, and the fire can't do anything. I used to work in a building that was an outbuilding where the servers were, and the whole building was argon infused. You had 10 seconds to get out.
Wow.
Yeah.
You
Otherwise, you had to hold your breath.
You must have been keen looking at where your exits were.
Well, no. Luckily, my desk was right next to the exit door.
Oh, useful.
There was someone who was at the other end, but yeah,
So I have to call
it was always a bit of a worry that, because we used to do tests and the klaxon come on and be like, get out, get out.
And it was out now.
Oh yeah, it's out. No messing about. No like faffing about having a chat, getting your coat. Right, but this was useless, and the reason it was useless is because a load of you didn't read the question at all, and that is a catalogue through this entire paper. Lots of, oh, I'm going to go off half-cocked. I've read half of it, don't need to read the rest, etc, etc. The next one is another example of this. You went into GCSE LAN and WAN, LAN versus WAN, LAN versus WAN. Where did it even mention WAN? It didn't. It's just saying they've connected them using a LAN. You've all seen the word LAN and started talking about LANs. Didn't say what is a LAN. Why do we use a LAN? It's saying what advantage is it of connecting the computers together. And it's all about managing the computers and sharing resources. That's why we have networks. To share resources, so you can mention different types of resources. So some people did sharing hardware like printers. You can log on to any computer and get access to your files because you've got shared servers. Easier to manage because all the computers connected. You can do updates across the network. You don't have to go around to each individual machine and do updates. Share internet connection if you've got an internet server. Okay. But you've got to answer the question that was asked. Oh, what is a network protocol? Two things you've always got to say. It's a set of rules. That's what protocol is. But a network protocol is a set of rules for sharing data across networks. The communication of data. That's all it is. Give the names of two protocols. Remember, this was the weird one. Let's pull the mark scheme up on this one.
Oh, is this the one where...
Yeah, I thought it was a bit mean.
If you wrote IMAP and POP or something, you'd get the mark. But if you wrote it as internet... Yeah,
right, there we go. Right, it says, one mark per protocol listed. Fair enough. It says, if mentioned one protocol with two versions, only one mark. Well, that's fair enough. If they've written the protocol in full but got any word wrong, no mark. But I think they should be explicit in the question, shouldn't they? They should say, you can either put the acronym or we want the full name. Not leave you guessing. So those people that put the full name and got a word wrong, let's say you didn't put protocol, you put something else. I don't think that's fair when all that anyone else has to do is put the acronym. Be careful with that. But the distinct protocols is really important. Right, why do we do layering? Right, layers. We can switch individual layers out, so we can change how an individual layer works without affecting the other layers. It allows us to debug issues with networks easier because we can narrow it down to a single layer problem. Is it an IP problem? Is it a TCP problem? Is it like the data packets? Is it a final routing to the MAC address problem? So the link layer? That's why. And you can change them. You can use different protocols in different layers. Sometimes they go together like TCP IP or SPX and IPX. Okay, so you would use pairs together. But there's nothing to stop you changing how you do your addressing at the end. But yeah, we use the layers for debugging and for the way that we can switch them out. Okay, it makes it easier. You don't have to focus on all of the communications, which is why we can do wired connections and wireless connections, because those two layers are different, and it doesn't matter. It doesn't affect TCP and IP if we're going through a wireless network or a wired network or a data network. You can switch that layer out for any of those three, and it doesn't affect the rest of it. Can you imagine what a nightmare it'd be if you changed whether you're on a wireless or a wired network and all the other stuff had to change? It'd be a nightmare. You wouldn't be able to do it. Right, the next one was another example of not reading the question. Why did it have to be question one? It made me incensed, this did. Right.
Should we just have a little note on the board though? You didn't read the damn question. You
Yeah.
just point it at every question.
No, I get tired. Right. So it says a computer owned by the business, so we're still going about this manufacturer. They're monitoring safety critical things. Input data must be processed within a predictable timescale of a fraction of a second, so quickly. State the type of operating system. They mean what mode is it running in. This has always been a problem with computer science A-level. They don't know what to call this. When they say type of operating system, they mean how does it operate. So they've said a short period of time is when we need a response, but that's what we call a real-time operating system. So you don't wait 5 days to go, yeah, that barrier's not down, someone might have their arms pulled off. You can't wait 5 days for that, because you'll have found out because someone got their arms pulled off. So we need a real-time response. Then when it says the three other types, it didn't mean Windows, Linux, Mac OS. It meant in relation to how they operate. So we've only got a few that we've talked about. So we've got single user, multi-user, we've got multitasking, and we've got distributed. We don't really talk about the other one, which is batch. Okay? Where you offline process things, so you collect a load of data, process it, dump it, ready for some other processing. Right, so with single user, you've got a computer system where one person can log on to it and use that computer one at a time. Okay? A bit like how we use our systems. With multi-user, you're talking about a computer system where multiple users can be logged on at the same time. So basically a server, web server, file server, print server, whatever it's being used for. Okay? Essentially. It's what mini computers and mainframe computers are. They're big computers that can handle multiple user connections, just like any server. Multitasking is an operating system that can run multiple tasks or seem to run multiple tasks at once. Remember, you can only truly run them at once if you've got more than one core. Otherwise, we're just on time slicing as a method of looking like we're running. And then distributed is where we've got work units and we supply them to different computers on that distributed operating system, so that we can shorten the amount of time it takes to process large jobs of data. Okay, distributed. So the operating system manages farming out the work units to all the other components that are on the network, which may be a mixture of things. You could have some CPU based stuff, you could have some GPU based stuff. It would handle all that. Distributed. The work is distributed, and the operating system handles that distribution and getting all the results back and compiling it or whatever it is it's doing. Okay, but reading the question, 6 marks. That was as much as the hardest programming question on the other paper. An easy question. And then dealing with interrupts, I think is nearly the last question. This one rattled on, this one, didn't it?
It did.
I'll stop after this one so I don't go over time, because I've been going for nearly 20. Right, operating system deals with interrupts. They seem to do this. Normally, we're processing a program. If an interrupt occurs, and we can look at the status register at the end of an instruction to find out that, if an interrupt occurs, we halt what we're doing, we work out what interrupt service routine, the ISR, is responsible for dealing with that interrupt. We then make sure that we save the state of the CPU. So we need to, at minimum, save the program counter before we go off and modify the program counter to point to the interrupt service routine. The interrupt service routine runs. When it finishes, it lets us know. So the CPU goes, right, okay, interrupt's finished. Let me restore the state of the CPU before the interrupt, and then I will carry on as if nothing happened. Okay? 3 marks, you could say 10 things. And there were quite a few bits on the mark scheme. So make sure you do have a look at that to see what sort of areas you've got to talk about. Okay? Whenever you're talking about interrupts, always say when an instruction's finished. Remember, we can't maintain the state of the CPU during the middle of an instruction. Right, I'll stop that one there.